So for our Aldol condensation product, if I can find it, 57B, I believe, was the Aldol condensation product. It's tantalid bromination product, the Aldol product. A 59A. I'm going to have to go check my notebook and make sure that actually is the right compound, because that could also be a product from the morpholine reaction. So we want to take an IR spectrum and we want to take a melting point on our Aldol condensation product to help us analyze it. And it looks like I'm good. 57 is my Aldol condensation. And we're going to try to get a GC mass spec on the Aldol condensation product as well, so we can fully characterize it. So I want to run an IR, and I'm going to use kit number 5 here, and I know it's clean because I just used it and cleaned and dried it. So we'll take a little bit of our solid out. Kind of a fluffy solid. That's probably enough. Doesn't take much. So grind that down. Smear it around the walls. As usual, the goal. Make sure I'm pointing at the right plot here. As usual, the goal is to get it so that it's sticky, so that when I tip this upside down I don't lose any compound. And then we'll add KBR, and we will use the KBR to sandpaper that off the walls. Just ran one with this KBR, so I know it's dry enough to get a good pellet with. Set that back there for now. So, and since it's a little more granular than I'd like for creating a really good pellet, I'm going to grind as well as mix. Try to get that compound off the mortar and pestle, both the mortar and the pestle, but also try to grind the KBR a little finer so that it will fuse more nicely into a pretty transparent glass. So that's pretty free-flowing now, relatively speaking. And I should be able to transfer that into my pellet die. Put the collar on. And I want to scoop about half of that material in. Tap it to uniformly distribute it around the base. We can put our lid on, and then we'll grab our wrench. And the last pellet, the setting that I needed was just a little bit off that mark, a little bit further open. We're going to pull that out. Insert that and squeeze it tight. I'll let that sit for a bit. And we can open it up. See if we got a decent pellet. And we do. It's relatively transparent. So it should give a good quality IR spectrum. Omnic should already be open. I left it open last time I used it, so we can collect a background. Background looks normal. Don't need to save those changes. Now I can collect my sample. First piece of data I'm collecting on this, and I don't know what it did. Go away. B-1. I'll put that in there. I'm going to try to make sure I put it in so it's as transparent as possible right at the hole. And okay. Back around 81 minutes, so we're in good shape. And we've got a nice looking spectrum. The baseline is sloped, but that's normal for a KBR pellet. And we have nicely in range, somewhere between 65% and about 20%, 24% transmittance, so that looks nice. I'm going to save it. And I will correct the baseline. Almost always necessary to correct the baseline on a KBR pellet. Grab that little end box. It's baseline there. It's baseline here. And I can make those so they're exactly on the line. Drag that end up. Now that looks pretty good. I'll move my name down to the bottom corner, and I will double click and enter as a comment. This is the Aldol condensation. Product. Between K1 and B2. Okay, that. I want to find peaks. And I do want that one. And I want some of these too, but I don't want all the really tiny peaks. So I'm going to set my line just below that peak at 2968, so it picks that one up. And replace. As usual, I will need to change my display limit, so instead of 65 here, I'm going to choose 57, which will put my peaks on scale so I can move them around. So I got a peak at 1668. I got two fairly strong peaks at 1603 and 1592. These are small, 1560 and 1508. 1455, that 1438 and 1415 peaks are quite weak. And what I'm going to do is compare these to the literature spectrum. Well, what you are going to do, this peak isn't real. I can delete that one. 1138, that's real. 1025, it's there. Small, but it's there. 947 and 959. 887 peak looks like it's probably real. That 912 peak may be real. So I'm just moving these around so that it's much more clear what they're pointing at. These two peaks here at 553 and 512 are unlikely to be significant. This peak here might be, so I'm going to label it. And then I definitely want this guy. Those regions are relevant. And it's worth picking a couple more in that region as well. So that looks good. Those are probably all the significant peaks labeled. We'll save the file. And we will print it. B-1. It's very unlikely that the product is in the search library, but let's search anyway. Yep, 4-hydroxybenzaldehyde, 40% match. That's terrible. There's no reason to print that. Let's do a spectral interpretation. And it thinks it's a para-substituted aromatic hydrocarbon, which is close. It's an ortho-substituted aliphatic hydrocarbon and a pyrrole. It's none of the above, and you can see that the regions that it's looking for are quite blank. So again, that's not useful. And that's not uncommon for multifunctional compounds like this aldol condensation product. So all we'll need is the actual spectrum for comparison to literature. Might as well save the changes. And we can put this computer to sleep and clean up our mess. So you don't need to watch me clean up.